Hello, everyone. Welcome back to our flipped classroom. Today, we're going to be working with the HR diagram, which is on your reference table on page 15. And as per usual, you are going to be listening along, following. You can pause the video when you need to write something down, replay if you didn't get something right or you want to just hear it again. And you're going to be answering the questions right here on our flipped diagram right here. Quick quiz, and we'll be going over it all tomorrow. All right, let's get started. And let's turn this pen on. Oh, no, that's not what I want. I want to do, there we go, the cursor. Okay, so this is what you'll find on page 15 in your reference table. They call it the characteristics of stars. That's the title of the diagram right at the top there. And in the world of astronomy, we call it the HR diagram. And it's an abbreviation for the two people who put the whole diagram together and made all the observations. Okay, so before we continue with today's video and introducing some new ideas, you should complete the recall portion of the quiz. You should be thinking about the words we were using in class and what does luminosity mean, which is a word that we'll see right here on our y-axis of the graph, luminosity. And what is the relationship between temperature and color? So what I want you to do is answer those questions on the recall portion of the Google form and submit it. Don't forget to put your name at the top, and you can pause right here and then we'll move on. So what we're going to be doing is looking at these different types of stars. So here we see in this bold font, we see 4 different kinds of stars. We have white dwarfs at the bottom. We have main sequence stars. We have giants, and we have supergiants. So what do these different groups mean? What is the difference between them? So on the y-axis, like I said, we have luminosity increasing from the bottom to the top. And notice that the scale is not your traditional scale you might have seen before. This is a logarithmic. And over here on the x-axis, we have temperature. But I want you to notice that temperature is increasing actually from right to left. So over here we have the coolest stars, and over here on the left we have the hottest stars. And I just want you to note, what color are the hottest stars? And what color are the coolest stars? Is that what you would expect? Let's think about that. So what I want to start off with is talking about the white dwarf stars, which you'll find at the bottom here. Let me see if I can write a bit. There we go. Okay, so we've got some white dwarfs. What are the characteristics of a white dwarf while you're looking at that? Well, I'm seeing white dwarfs are very low on luminosity. So that means not very bright. And I'm also seeing that they're pretty far to the left around a blue-white color. What else do we know about white dwarfs? We know they are the end, late stage of the star cycle. Late stage cycle. We know the radius of a white dwarf, how big it is, could be about the size of the Earth, but the mass of it could be as massive as the sun, as our sun. And Something interesting about it is it's mostly carbon and it will cool off. So in theory, a white dwarf, we've never been on one, but could be a diamond in theory due to the high pressure and the density of it and its composition, which is carbon, which we know is what makes up a diamond. So I want you to copy this stage down and observe where we see it. And what we'll also see on this graph is this little circle sign with a plus in it. What does that mean? What does that mean? Now up here is almost a key. It says name in italics refers to a star represented by that symbol. So we know that the white dwarfs include stars like Eridani B and Procyon B. Now, if you're wondering, what does that look like? Here we have an image of Procyon B. Let me make sure this will go through here. I'll just copy it into here it is. Wow, look at that. So as you can see, it seems pretty white in color here, pretty small. We're not really seeing it in comparison to anything, but if you want in your spare time, you can look up some more images of that. So next we're going to move on to the red giants. So where on the chart do we see the red giants? Okay, right. So we're seeing red giants right here, and it says intermediate stage beneath it, right? So intermediate stage, that's important because later we're going to be talking about what all of these stages mean. So here for the giants, I'm seeing they are cool in temperature, right? On the low end of the spectrum here, and about red in color. That's why we call them the red giants. Red color and very cool. However, they're very bright, right? They're pretty high up, or if you're going upwards on the graph, they're pretty high. I'm seeing around a 1000 luminosity. That's very bright. So you can see them very well, and they're large in size, right? And very massive. As we can see on the right side, we have another indicator, so how massive these stars are. Next, we have something a bit more interesting and diverse. We have main sequence stars. Now, what are main sequence stars? Main sequence stars they include this entire diagonal sequence of stars. And you can look at some of these names of the stars. You've got Barnard's star, Alpha Centauri, Sun, Sirius, Spica. Wait, one of those sounds pretty familiar, am I right? Sun. Let's think about that. So for main sequence stars, they as they get hotter to the left, they get brighter. Brighter equals hotter, and dimmer equals cooler. Includes the sun. Right? And what other we see these other stars. So we'll look into what that means for us. And one more thing I want you to think about as you bring this into class tomorrow is we have this characteristics of stars, and we have the white dwarfs, we have the main sequence, giants, supergiants. Do you have any questions about maybe what's missing? Think about that, right? Maybe write some questions down. What do you think is missing in this graph? And in class tomorrow, we'll be identifying stars using their identifying characteristics, which are temperature and brightness on this diagram. I want you to know where the sun is located on the graph, and we're going to look into what is the temperature and brightness of our sun. So we're going to use this graph to